you guys able to see my screen?
Yes.
All right.
Yes.
Greetings, everyone. A warm welcome to Exchanging Ideas 9 Global 5G Evolution. Kindly take a second to subscribe this YouTube channel by clicking the subscribe button. And I'm 𝗘𝘃𝗽𝗍𝗂𝗧. A big welcome to this YouTube channel Global 5G Evolution. It's a pleasure to have this wonderful session with everyone. A thankful welcome to great speakers around the globe. Now, to start on, I will present on the topic of 5G private network in Japan. As you can see on this screen here, this is the latest Fujitsu in Japan, where Fujitsu was granted Japan's first commercial private 5G radio station license from the Kanto Bureau of Telecommunications, and it begins operating as a private 5G network at its Kawasaki's office. Fujitsu will strengthen crime prevention measures in the building by leveraging its private 5G technology for data transmission of high definition images collected by multi-point cameras, creating an AI powered security system that quickly detects a suspicious behavior through a motion analysis. So through its newly established private 5G co-creation, it's a space where Fujitsu is building a collaboration lab. Fujitsu will offer customers and partners a chance to workshop various use cases for private 5G to deliver business innovation and help resolve regional issues. So the aim of creating a smart factory on top of the Kawasaki office, Fujitsu also additionally obtaining a license for private 5G at its Oyama plant in Tochigi Prefecture, which serves as a manufacturing base for network equipment. Now, currently what Fujitsu has is a 5G non-standalone with the 5G for data transmission and LTE for connection control between the base station and the land mobile stations. And the frequency currently that is being used for the 5G is between 28.2 gigahertz to 28.3 gigahertz. And the LTE, it's used as 2575 to 2595 megahertz. And the coverage area approximately is about 28,000 square meters. Now moving on to the next slide. This is the private wireless cloud services, right? As you can see, the structure that has been built right now in Kawasaki office, which comprise the private 5G devices connecting to the private 5G network and the edge computing and towards to the cloud. So Fujitsu announced its collaboration with Microsoft, verifying the effectiveness of a system that uses private 5G to visualize real-time data with the facility, with a view towards the manufacturer's digitalizing transformation, where they are using Microsoft Azure IoT Edge in the Fujitsu Collaboration Labs. And this system analyzes with high definition images of people moving in the private 5G network and operating data from cameras, mobile terminals, servers, and other equipments. And this enables integrated visualization of the status of people, unmanned vehicles, and equipment with the Fujitsu manufacturing industry solution using the Colmina data visualization as the industrial app. So with the combination of the unifying the private 5G and the cloud environment to bring about an optimized network and a processing load, and this whole setup is being planned at the Fujitsu plant in the Oyama. Now moving on to the next slide. This is in the manufacturing industry to show a clear details of the use cases that's planned in the Oyama plant. And basically the manufacturing industry is to improve the efficiency, the automation effectiveness, and also the remote capabilities, of the operations through a digitalization, while maintaining the quality that will transform the manufacturing sites to make them to a more resilient, right? So private 5G enables enterprise in flexibility and operate the 5G network in their own buildings, and is expected to be used for unmanned and remote control at manufacturing sites. So this is applicable in a large amount of sensor data and high definition video for optimized utilization to the requirements of network application processing load. Now moving to the next slide, this is quite an interesting part, which is the private wireless managed services. Fujitsu will begin offering a comprehensive service to support the customers using the private 5G, where they have this collaboration with various partners in the industry. So when it comes to private wireless managed services, it provides a one-stop service from Fujitsu wireless technology specialists for measuring the and designing and building, operating and maintaining the private 5G system. What we can see on this slide here, it starts from a POC test on the base stations, followed by the implementation preparation, and then the design, construction, and the operation maintenance. This is something that Fujitsu is planning to launch to open market to any manufacturing factories to start acquire or purchase the monthly setup cost. Now, moving on to the next slide here, coming back again to the private wireless cloud services that offers a robust support, reducing the initial deployment costs. So Fujitsu, with the private partnership program, offering customers a wide variety of use cases and solutions that develop using 5G in cooperation with the partner companies. So the services offers base stations, the core network, and also the service management, inclusive the service operation management, license management, and administration portal. So it's a very simple concept with a low initial installation cost and also a monthly subscription kind of cost. So now moving on to the next slide. This is about the private 5G partnership program, right? So Fujitsu has been promoting the use of private 5G through in-house verification. So basically, it's just to want to make sure that there's, when it comes to the verification of connectivity with the private 5G network. So Fujitsu also will create and offer customers a wide variety of use cases and solutions developed utilizing private 5G in cooperation with partner companies, right? So the interesting part on the 5G partnership program, those partners that already have signed up in Japan, companies like Equity, INC, Edward, Techno, Mnemo, INC, Canon Marketing Japan, Silex Technology, Sharp Corporation, Taiyo Yoden, Trend Micro, Microsoft Japan, Magnica, Murata Machinery, Meta Water Limited, E-Digital Corporation. And when it comes to technical support in the area of core networks and semiconductors, there's a good strong lineup of 5G technology infrastructure partners, which is the Intel, Ericsson Japan, Keysight Technologies, and Qualcomm Japan. And this is the last slide, quite an interesting slide when it comes to the pricing. I couldn't able to get at this point of time the exact pricing for the private wireless managed services, but when it comes to the private wireless cloud services, the initial cost that is Fujitsu is charging is about 9,600 USD, right? And then followed by a monthly usage fee, which comes for about 3,840 USD, right? So Fujitsu has set a revenue target of 100 billion yen, which translates about 9.5 billion USD by 2025. That means that is a huge potential of opportunity when it comes to private network, targeting particularly in manufacturing industry, when it comes to the Japan, right? And also when the other parts of the world, like in US and Germany and UK and most of the Europe countries. The other part I would like to stress is Fujitsu has noted that 4.7 gigahertz band standalone is scheduled to be released early in 2021, right? So that 4.7 gigahertz band base station will be a massive rollout for Fujitsu in Japan. So I think that is overall presentation from me. So let's move on to the next speaker. I would like to introduce 𝗬𝘂𝗽𝗽𝗀 from Sydney, Australia, to present on the fixed wireless access.
Hi everyone, thanks Dr. Kanish for allowing me to speak to this great group of people. Let me share my screen first. Can you see my screen?
Yes. Perfect.
Okay. So welcome again, everyone. So my name is 𝗬𝘂𝗽𝗽𝗀. I'm a principal solution architect and recently promoted as CTO for a company working mainly with telecommunication when it's come to the design and implementation of the transport and access layer. I'm also an author and trainer with more than 20 years of experience in telecommunication in Europe, Middle East, Africa, and now in Asia Pac. So today I will try to touch base on two topics, trying just to set the floor for my colleagues to explore more about what do we mean by fixed wireless access and give quite a few updates about 5G private network business model. So when we talk about fixed wireless access, I thought to start by explaining the predecessor of it, which is we have it for few decades now, which is a fixed broadband. So when we talk about fixed broadband, if you can see my screen here, usually when you are at your home, you have a small CPE modem, regardless, yani ONT, it depends on the access technology you have. Usually you have a CPE which will be able to serve you to get connected to the internet. So usually you have this CPE at home and you have multiple access technologies like OLT, VDSL, FTTX, which include fiber to the home, fiber to the building, fiber to the care, and so on. So the challenge was with this technology that the access part of it or the last mile, it either can be copper, cable, or fiber. And all usually this is an expensive investment from the communication service provider or internet service provider. Then you have the aggregation layer, which can be DWDM, dark fiber, whatever, which connect you back to the transport network. And then you have the normal, sorry, I'll go back to, then you have the normal BNG, which is the border for the network, for the broadband. So you can get authenticated and you get the right bandwidth and the right privilege for you. And after that, you have the service layer. So this is a normal setup for the fixed broadband. As I highlighted, the challenge with this model is the lead time to connect. So if you are in a specific area and you ask for this fiber to the home, sometimes it takes to few weeks to few months, depends on the how ready is the area and how ready is the aggregation layer close to your home. And in some other location, maybe fiber to the home will not be an option. Maybe your best option is to have fiber to the curb. This will, and then up to your home, they will have maybe a sort of copper or so on. This actually affecting heavily your bandwidth, which you will get from this service provider. So it may drop from 10 meg to 1 meg or even less. In addition to, as I mentioned, to run and maintain all this fiber and copper connectivity actually is a huge job, require a lot of CapEx and also OpEx investment from you as a service provider. If you compare this, that's why the number of fixed broadband was still up to the 1.1 billion compared to the mobile broadband, which almost achieving 6 billion subscription now. This is because it's easier to build the wireless connectivity and everybody can get benefits from it. So what is the promise of fixed wireless access? But before we going there, let me highlight an important piece of information from Cisco annual internet report. which predict the number of internet users from 2018 to 2023. As you can see, we can see around 6% growth every year. So we are almost reaching 5.3 billion users connected to the internet. The challenge with the fixed broadband, you cannot reach each and every place with this fiber connectivity or copper connectivity. So rural area, regional area, the places where it will be difficult and not cost effective to deliver copper or fiber there, you need to find a solution which will be, I believe, fixed wireless will be a perfect fit for that. So this actually for CSP will be lowering their network cost. They will improve their revenue, and actually they will add a new market for them, and for sure improve their time to market. So if you have an area which already covered by mobile and you have your base station, maybe you just to introduce 5G, or even it's allowed in LTE advanced, then you can deliver this internet connectivity to the home. Just before going that, this fixed wireless access it's different than tethering, or when you have, like, example, a CPE which support backup as a mobile broadband as a backup. So this is not the same case. For the fixed wireless access, usually you have a CPE and you have an outdoor antenna. This outdoor antenna will actually authenticate you with the base station, which will provide you with a guaranteed services and better quality of experience. When it comes to the business model and the revenue stream, as you can see here, over the last year, and this is I kept this actually source is from Ericsson report for this year. As you can see, in the last year, the number of service providers offering fixed wireless access increased heavily. So I believe now, the last month, I believe this number grew to around 200 service providers worldwide offering this service. And as you can see here, this is the percentage per region. As you can see, Western Europe is leading this graph, followed by Central Europe. Also, I believe North America is very close, and also Asia Pacific. So if you consider like how the current CSP can benefit from this service, I'm just watching the time. You can see we have a couple of things. If you are already a greenfield mobile operator, this would be a perfect fit for you, because currently you don't have asset, and instead of trying to build all this fiber and establish all of that, you can, as I mentioned, you can utilize your mobile base station and or your radio layer to get the internet access to the current user. If you are already a fixed operator and maybe you have a lot of DSL and copper connectivity, many of them now, they are having an analysis how to replace this copper. So if they want to replace this copper due to the large and huge investment from OPEX and for the copper and fiber, I believe fiber fixed wireless access will be also very appealing for this kind of CSP. Finally, as I mentioned, if you are converged operator, which you are provide mobile and fixed services to your customer, this also will be very brilliant for you, because you can utilize your existing asset, like you can utilize your transport layer, you can utilize your mobile core, maybe you can create a new APN or a new network slice and give access to this mobile user utilizing all the existing assets that you have. Just a couple of more slides about 5G private network. So as I mentioned, 5G private network can be very scalable. You can start, or you have multiple flavors. You can start from completely pure private network, even considering you have your own spectrum, you have your own dedicated spectrum on the RAN, completely separate network up to the mobile core, without even any access or any integration with the public network. This includes the public mobile network and the public internet. This is the one extreme, which you have a completely private network, very secure, very reliable, dedicated for you. Then you can have multiple flavor, starting maybe even you can have just a private slice over the public network. Just to give you a quick update, like I believe this 5G private network is booming. As you can see, this is like a a snapshot from Nokia about their latest private network solution. And as you can see, they stress on the security. So if you are really an enterprise and you want to make sure you are securing your data, you're securing your intellectual property, your R&D documentation, you want to secure the communication between your department, maybe will be an appealing reason for your company to go for a private network. And also, as I mentioned, instead of maybe investing in fiber and connectivity, which is a bit expensive, you can utilize the wireless connectivity. I'm sure I will speed up a bit. And this is another example from Ericsson, how this private network can help in the healthcare. And finally, as you can see here in Australia, our tier one service provider, Telstra, which is a converged service provider for fixed and mobile, they just announced the 5G private network, which can, as I mentioned, it can give you a great speed, low latency, and high security and resiliency. As a conclusion, what I want you to take off from this session, that fixed wireless access will provide many benefits, including better time to market, including maybe you can start selling over-the-top services, try to improve the ARPU, average revenue per user, which is normally around $50 to $100. So providing these services will add to it. And finally, 5G private network can provide a lot of business model ranging from completely separated network to just a slice over the public network. Once again, thank you, and I will be available here if anybody have any question at the end of this session.
Excellent, Mohammad Radwan. Thank you so much.
Thank you.
Now moving on to the next speaker, David Gallegos, Guadalajara, Mexico, would like to present on the 5G private network spectrum regulatory.
Thank you, Ganesh. Hi, everyone. Thank you for the opportunity. I will talk about the 5G public and private spectrum regulatory in LATAM with the specific cases for Mexico and Brazil. Briefly introducing myself, I've been working as an engineer in network performance optimization in Motorola and Bell South in 1997. Then for 10 years in Latin America and USA with network optimization. Since 2005 at the Nokia Institute of Technology with the research, communication, and wireless technologies. Since 2015 as technical director in 𝗘𝗃𝗽𝗃𝐺𝗍 Mobile, and currently as an executive technical advisor for telcos and startups through NewtonX. I also have some publication in the 𝗬𝗃𝗽𝗃𝐵TC and 𝗬𝗃𝗃 Communication magazines, and also a contributor for GSM Evolution and Performance book that was written by jointly with Nokia and Siemens staff. So just to understand the background spectrum issues that we normally have had in LATAM, you can see two cases of the GSM 1900 with WCDMA, the MTS 2100, specifically in Brazil, and the situation that we have also for the TV broadcast and the LTE at 700 megahertz. In both cases, we need to have some specific allocation for spectrum adjustment, refarming, rearrangement, and also the application of some low noise amplifier filters for those. If you remember, in some countries in Latin America, for this case specifically, have a spectrum allocation with the American and the European approach. That is the case of Brazil. In relation to the status of the spectrum allocation, we can say that the focus reference for the baseline, the harmonized baseline, is on this green area of 3.4 to 3.6 gigahertz. However, in LATAM, we are trying to reach this spectrum with 500 megahertz from 3.3 to 3.8 gigahertz. Some countries already with clean spectrum already have some space from 100 to 400 megahertz, specifically for Colombia, Chile, Mexico, and Peru. And there are another countries that have this spectrum already occupied. That is the case of Argentina and Brazil. Most of the countries has plans for auctions in 2021. Supposedly it should be this year, but as per pandemic COVID-19, it should be postponed. We understand that more spectrum, we should have better performance, quality, and higher data rates, and also the expansion of new services. This is on a specific case for Mexico, but this scenario that we have in the past in Mexico is some of the scenarios that we currently have with some operators, is the fragmentation of the spectrum. So we cannot have a continuous 50 megahertz block allocation in some countries. The Mexican case already got it with the allocation that they have in the past with certain fixed line operators. Specifically for the case of American Mobile Group, that is Telmex and Telcel, Telmex has transferred already 50 megahertz to Telcel, that is the wireless operator, and also Telcel has backed these 50 megahertz from Axtel. So this is one of the operators that already has some 100 continuous allocation for spectrum. Interesting to say is that the prices paid at that time was 15 cents compared what has been paid by certain operators in Asia and Europe that is 10 or 15 times more, right? So this is something that we need to focus in Latin America in relation to the prices that we are going to approach in the next slide. In relation to the 6 gigahertz, there is a momentum for this in Latin America because more and more consultations in Mexico and Colombia, for example, at this frequency band, we have the utilization for digital radio links, specifically for backhaul transmission. But there are some countries like Chile that already decided for the entire 6 gigahertz bands be allocated for Wi-Fi 6E. That was last month for some indoor and certain conditions for the power transmission. Other countries like Brazil and Peru, for example, have an open evaluation still pending, but the idea is to have a mixed coexistence. From the operator or network vendor perspective, they stand for a division. The lower part of the band be with Wi-Fi 6E and the upper band for licensed 5G. Here is a resume and a summary of what we can have. A full license allocation for only Wi-Fi 6E, or an unlicensed combination of Wi-Fi 6E with 5G new radio unlicensed, or a separated Wi-Fi unlicensed with a licensed 5G new radio from the upper bands. So this is still some pending decisions that the office regulators need to do. For the other application of private networks in Latam and also other 5G spectrum, we can say that specifically for Brazil is marking the pace with 100 megahertz at 3.7, 3.8 gigahertz, and also the band N79 from 4.4 to 5 gigahertz. The specific applications are mainly for agriculture, mining, and oil and gas industries. Other bands, in addition to what we have already for LTE and the 5G of 3.5 gigahertz, are this one: 600 for Mexico and Argentina, 700 megahertz for Brazil and Chile. The 26 gigahertz, all these countries, Mexico, Argentina, Peru, and Brazil, perhaps is the most common, popular, and the 28 for Argentina and Chile. Other countries are more or less following the same approach. The last topic, when we go with the current spectrum challenges, specifically for Brazil, is interesting because there are some executive orders from the government where there are low-income families in certain areas of Brazil that needs and must continue to have the television reception TVRO services. And what happens at these 3.5 gigahertz, there are several services. There are a lot of residences in Brazil that still have the only services for education and entertainment basic purposes, right? This is something that is causing some kind of attrition in relation to the decision that the office telecom regulator need to do. The current idea is that it should be used the 3.5 gigahertz for 5G, and the operators that win the auction, we need to assume responsibility to have the installation of filters, LNBF filters, in order to clean and mitigate the interference that will be caused of these stations, right? Like, for example, the idea at this stage is the calculation for almost 17 million home residences to be allocated to the co-band. It will cost like $100 per residence, when compared with the approach to keep the band C at $40 for 7.4 million home residences. So this is the same case of Argentina as well, okay? Here an example of how will be the application of the satellite carriers with the 5G carriers. The another challenge that we have here is that some of the countries need to do refarming in the spectrum in order to have continuous at least 50 or 100 megahertz, like Peru, for example. Also, in this graph, it's interesting to see, for example, that this blue dark line is the recommendation from ITU for high density places that you need to have around 2 gigahertz of spectrum. What is interesting is that countries like Brazil, which is Sao Paulo, Mexico, where is Mexico City, and Peru, where is Lima, there are cities with more than 10 million population, still has less than the minimum specified for low density cities. So there is a huge challenge here in order to get the proper spectrum, considering that 5G is a technology that needs to operate with the suitable amount of spectrum, right? A challenge will be to have 80 to 100 megahertz per operator. In Brazil, for example, we are speaking about 80 megahertz, perhaps. And this is a challenge that we have. And finally, for the Mexican case, this topic, my last slide, is some operators already paid for this band, 3.5 gigahertz, but it's possible that need to pay additional amount in order to keep the utilization of this band. Well, thank you everyone for the opportunity.
Ganesh, your mic is off.
Thank you. Thank you, David. That was an excellent presentation. And now moving on to the next speaker, let me introduce Professor David Gómez Boquero from Valencia, Spain, to present on FUDGE, 5G fully disaggregated private network.
Thank you, Ganesh, for the introduction. My name is Professor David Gómez Barquero. I'm the project coordinator of 5G, which is a research project here in Europe that focuses on customized cloud-native 5G private networks. The main motivation for the project was that 5G private networks will require customized solutions because the number of industry verticals is huge, and each will have different requirements, and therefore it's very important to be, there will not be a single 5G private network that capable of meeting all the requirements. And we also, as I said, we focus on virtualized and cloud-native private networks. Well, the project started recently, last September. It will run for 30 months. And in this presentation, I will focus on the 5 use cases that we intend to demonstrate and all the novelties that we will bring. Here you have the consortium. It's a mix of, on one side, high-tech SMEs, all bringing different 5G components. We have large 5G vendors as well. Mobile operator, Telenor from Norway, because all the use cases will be demonstrated there on top of the 5G 𝗍𝗍 experimentation platform, and well, also some research institutes like Fraunhofer Focus and well, the Technical University of Valencia, where I belong. Here you have like a list of the main technical innovations. I will explain them later. But well, to mention just a few, we are working towards a unified service-based architecture, meaning that we also want to include within the SVA the user data plane, not only the control plane. We are also working towards developing 5G core network functions as microservices that can be deployed either at the edge or in the cloud, or as well on premise. A very important feature for private networks will be the LAN native support, meaning that you can combine like a fixed LAN with Wi-Fi and 5G into what we call an all Ethernet access. And well, you have there the complete list. We'll mention well some synchronization aspects, and we will also address the interconnection of non-public networks with public networks and different setups. Here you have the high-level architecture. And well, basically, yes, this is a way to highlight also the innovation. So we will have some innovative features for the user plane, including these cloud native 5G core network functions. The project also tackles service routing and resource scheduling for the 5G core network functions and related traffic. The all Ethernet access, having like different technologies and being transparent from the users or devices. I will present you 5 use cases, each with a stakeholder, which is the final end user. The project, we will also work on orchestration and lifecycle management of the virtualized resources, and well, also addressing the infrastructure as a service. This is the ongoing work regarding the platform architecture that we are designing currently, and later on we will develop. Here the innovations are at a more detailed technical level, but I will go through this, and I think in this I will focus more on the use cases. But well, there you can see basically the innovations I have already discussed, but maybe with a more detailed information from an architecture point of view. So, for example, here you have the 5G LAN, the 5G TSM for synchronization, opportunistic multicast, the orchestration and lifecycle management, and well, from the verticals applications. So regarding the 5 use cases, in all of them we have a stakeholder. For the media use case, we have the Norwegian Public Broadcasters, NRK. And well, as you can see here, we have like a private network where we have on one side a live television content production. In this part, we will test innovative new radio features. So for example, super uplink or bandwidth parts. And then we will have what we call a media showroom, which is well, a place with a lot of users and where we will demonstrate, for example, opportunistic multicast in addition to this 5G LAN functionality. In this use case, for example, we will make a multi-vendor setup where the control plane is on the cloud and the user plane on the premise, and with different 5GC vendors. And we will also test different deployment options for like a hybrid or cloud premises deployment. Regarding the, we have another use case is on PPDR. And the stakeholder is the Norwegian Defense Materiel Agency. And what we aim here is to build a non-public 5G network, which is transported in a vehicle. And this network works even when there is no other infrastructure available. This one of the main characteristics is that it will be easy to deploy and fast to configure. And as I was saying before, it should also work in a standalone. We are calling this autonomous edge. And well, being a PPDR use case here, everything related to security, it's of course very important. And as I explained before, we will also address the possibility of connecting this private 5G network with the public network and keeping all the security and reliability constraints of the stakeholder. We have our third use case. We call it hospital virtual office use case. We are talking a lot about the future 5G virtual offices, which will be enabled by either private networks combined with 5G LAN, having this unified all Ethernet access. And in the project, what we are focusing on for this specific use case is to apply it to a hospital. So the idea is that in the hospital, there is a private network. It provides isolation for all the information and devices. But in this case, there will be some interconnection of the private network with the public network in order to reach coverage outside the hospital, for example, and even to reach for example, ambulances that are in the city and are outside the reach of the private network. So in this case, the main innovations are, well, the use case is built around this all Ethernet access concept, and then as well security aspects. So this interconnection between the public network and the private network can be done keeping well, all the security and constraints. The stakeholder is, in this case, the Oslo University Hospital. Our fourth use case is on Industry 4.0. Here, the stakeholder is ABB, and this use case is progressing a bit slower because there was actually a change in the stakeholder. So basically, the ideas we have is to showcase 5G TSM. You know, this protocol for timing and synchronization, and another of the new features will be a new and a specific developed 5G gateway or modem for industrial applications. And our fifth and final use case, we call it 5G 𝗬𝗏. Maybe some of you you are not familiar with 𝗬𝗏. It's like a network among all the, well, not all, many universities, not only in Europe, but also worldwide. And for example, if I go to another university abroad that belongs to 𝗬𝗏, I can log in using my credentials from my own university. So in this use case, what we plan to do is to interconnect 3 private networks in different countries. One in Berlin, in the campus of Fraunhofer Focus Research Institute, another one in Telenor in Norway, and also the third one will be here in Valencia in Spain. So currently the 3GPP specs do not specify how private networks should be interconnected. And so that will be one of the main innovations in this use case. And it's also a use case built around this 5G LAN and all Ethernet access paradigm. But here it will be also very important, the distributed authentication framework, so that we basically replicate or the authentication mechanism of 𝗬𝗏, so that you can actually go to a different private network and interconnect or log in with your own credentials. So it's not exactly roaming, but well, there is some difference. And well, that's it from my side. I have many technical details that I have skipped, but well, if you have any question later on, I'm happy to answer them. And if not, well, in the public webpage of the project, you will find all the information.
Brilliant presentation. Thank you, Professor David.
Well, my pleasure. Ganesh.
Now let's move on to the next speaker. Let me introduce 𝗬𝗪 from Barcelona, Spain, to present an ORAN architecture to boost 5G private networks.
Good morning, everyone. Thank you very much, Ganesh, for this opportunity. My name is 𝗬𝗪. I am the SVP of Technology and Marketing at Airspan. Just a brief introduction of what is Airspan. Airspan is an American-based company. We have been designing and developing radios for the last 20 years. Our radios try to disrupt the market and break the status quo of traditional radio vendors, by leveraging innovation and also using open architectures, open interfaces. We are being focused now very much in 5G, bringing our full solution from the radio and also the software part, so the CU, the DU, the RIC, and we have big successes in like Rakuten. We are part of Rakuten network, and also we have a big take now in private networks, which is the topic of this discussion. Let me share my presentation quickly. So if we look at private networks, it's a market that you can see that many forecasts and many analysts are forecasting like a booming market. You can see that we have growth of 17% CAGR. This is a conservative report, but and this is in the CBRS US market. But if you look at European market, we have similar forecasts. So there is a big opportunity in these markets. The reason being is that many customers, private networks, they require a new technology. They're requiring a cellular network technology, meaning that they need 4G or 5G. Current technologies, mainly Wi-Fi, which are good for certain aspects of private networks, they don't cover all the requirements. And you can see here in this survey what are the needs that are not covered by other technologies, right? Mainly Wi-Fi. So you can see that they need networks that are more reliable, more secure. They need more throughputs, of course, always less expensive, scalable. Mobility is a big thing that, for example, Wi-Fi is not so good at. So this is why these cellular networks is important for private networks. If we look at the key features of 5G, for example, we can see that 5G is like increasing the number of features you have that really fits nicely the private network environment. If you see the main three features that 5G brings, that everyone knows, is the higher throughput, more connected devices, and also lower latencies. But if we look deeper into the features of 5G, we have features that work very nicely with private networks, like, for example, network slicing, having independent networks connected in the same network architecture, for example, positioning services, meaning that you have a better distance accuracy to locate objects, right, or moving objects like vehicles. Mobility also is a key feature for these private networks, and also the advanced quality of service, not only per user but also per data flow. So all these benefits, all these new features from 5G really fits nicely with private networks. But the reason of the booming market of private networks is technology, is 5G, even though we had 4G before and private networks were not so well, so mostly adapted worldwide. The reason being of private networks now are becoming very successful is because of the spectrum. If you look before, and we can put like a timestamp of 2019, so before 5G, basically the spectrum was given to MNOs, so that means to mobile operators, right? So there was not dedicated spectrum. It was not so very common to have dedicated spectrum for the enterprise. So if an enterprise wanted to build a private network, they had to go with the MNOs. And this is something that normally sometimes doesn't work very good, because private networks, they're very concerned about the privacy of their data, right? So they don't want to have their data flowing, through a third-party MNO, right? They want to keep everything inside premises. This has been a paradigm shift now with 5G, and also the change on the view of the regulators and countries. And we can see that many countries now, they are opening the spectrum and giving dedicated spectrum for the enterprise. And this is the case, for example, CBRS in the US, right, in the 3.5 gigahertz. But we have others like, for example, in the UK, Ofcom, that they give a spectrum for 4G, but also 5G in the sub-6 and millimeter wave, or Germany, for example, 100 megahertz in sub-6. So we can see that having this spectrum that is very affordable really opens up the private networks opportunity. And this is something that we at Airspan, we are seeing. We get like many system integrators from these European countries knocking our doors, asking to create these 5G radios. Also, the CBRS market is booming. We can see that, for rural coverage, education, hospitals, all these private networks now, they have a lot of interest because they can get cheap spectrum and it's dedicated for them, right? So I think this is one of the main reasons why private networks are booming, also together with 5G. But the main question of this talk is like, why OpenRAN? I'm sure that you have heard about OpenRAN. It's one of the hot topics that we hear in all the webinars talking about 5G. And what we believe is that OpenRAN, what brings is like a reduction of the cost of your network. You have a faster innovation, and also it's more secure. And let me go quickly in more detail about these topics. Let's look at a comparison of what is a traditional RAN and what is an open RAN, right? So if we look at the traditional RAN, I depicted here, if you see like 3 columns, each column is like a allocation. So you have, for example, on the right side, a main building, then you have an edge site. Edge site means could be another building or a cabinet close to the radio site, to the cell site. And finally, you have the cell site. The cell site basically is where you have the radio with the antennas, right? When you see a traditional RAN, normally you have the 5G core in the main building, then you have some connectivity, some transport to reach the radio, and the radio is everything located at the same location, what is called the cell site, right? So you have the radio, the RU, and what is called the baseband unit, BBU. This BBU is a proprietary hardware and a proprietary software that runs along the radio, the antennas, the filters, the amplifiers. So if we look at this traditional deployment, we can see that this is like a black box, right? You have everything proprietary, right? It works. So if you want to have a 5G, you're going to have a 5G network, but the flexibility is not that good, right? What OpenRAN did is basically took the original configuration of the radio and the software at cell site, and what it did is like, okay, let's move the software far away from the radio. So if you see now, the software is distributed in different locations. You can have them in the main building together with the 5G core. This is what is called the CU, the central unit, and then you have another part of the software of the radio that runs at the edge side, what is called the distributed unit. And if you see, all the interfaces are standardized. So one is defined by O-RAN, the other one is defined by 3GPP. So all these interfaces are being open, means that you can exchange parts of the full radio system. The first benefit that we see here is that now the radio is much simpler, right? It doesn't have so many layers of software. So that means that your radio is cheaper. And if you think about radios, radio is the element that you have the most in a network, meaning that now you're reducing the overall cost of your radios. Then we look at the software. In traditional networks, software runs in proprietary hardware. Now this software, if you see here, they run in the DU and the CU, and this DU-CU software runs on commercial off-the-shelf, meaning that is white-level servers. So any servers that you have from your IT department, you can use as long as they meet the requirements. So you are also reducing the price on where the software is running. Also, you have an advantage called resource pooling. If you see, the software has moved away from the radios, the software you can think of like the brain of the radio. So now this software is interacting with many radio hardware, right? So that means that you don't have, you are more efficient on these resources that are required for this software, right? Meaning that you need less resources. You don't have to over-dimension each radio like in traditional networks. So you also have this benefit on cost. Of course, maintenance is cheaper. The software that you run, now the radios is containerized. So it's running containers, running on the virtual infrastructure. So you can, for example, really like increase capacity or upgrade the network using these containers. So what it means is that you don't have to switch off the radio for these upgrades. So it's really on the fly maintenance. So everything reduced the CapEx and the OpEx related to the TCO. Also, this architecture brings the flexibility of having your sensitive parts of the networks located on premises. For example, your data privacy is very important for private networks. So what we can do here is like everything that is related with data be in a specific location, right? And also, you know where the data is flowing. So all these are the advantages that we have from this architecture. Another big advantage that we have is the open APIs. O-RAN Alliance really, one of the main principles they have 3 principles, is to create open APIs. Basically, what it means is that we can have the analogy of a mobile phone, right? When you have applications, right, and they run on an application on your device, right, through the application store. So you have your Android and your iOS, and you can install any application, third-party software. What OpenRAN is doing is like is trying to become the RAN as the App Store, meaning that now, thanks to these APIs, the open APIs, you can have third-party software companies bringing new algorithms running, for example, in the RAN intelligent controller, or you can have your own application. That this is something that is very common in private networks. They have in-house applications that they can run together with the radio. So that means that they can collect real-life information from real-time information from the radio and interact with the radio. For example, you can know what is the exact quality of signal that you have a device or a user, or you can know, for example, what is the latency in that precise moment, or the congestion, right? And having this live feed of information really improve your processes thanks to these third-party applications. So this is something that comes with OpenRAN that is not possible. It's not possible with traditional vendors. The last part, and also big concern, is about security. When we look at traditional vendors, you have one vendor focused on security, which is fine. But when you look at O-RAN Alliance, we're talking about 25 tier 1 MNOs, AT&T, Vodafone, Telefónicas, and you have more than 200 vendors like Airspan, but also you have like software vendors, core network vendors, like software vendors. Everyone is supporting this alliance and bringing this coding for these open standards interfaces. So everyone is looking at these securities. That means that you have many eyes looking at the security of these interfaces. So O-RAN, we believe, is more secure than traditional vendors. And you have, for example, you don't have any backdoor threats. That is a common concern that we see nowadays, meaning that now for private networks, the data, where it's located all the time, and also how your data is flowing inside your networks, which is very important for private networks. And also you don't have any vendor lock-in, meaning that if you want to have a new radio, for example, hardware from someone else, you can run, for example, Airspan software and then put another radio from another vendor because whatever functionality it has. Also, you can have other software from other vendor and have it in your network. So at the end, what you have is like a future-proof network, 5G, right? Having, improving this innovation. So just to finalize this 10 minutes presentation, just to let you know that we are fully active at private networks, 4G and 5G, and we are happy to hear from you. If you want to know something from us, you can contact us on our webpage. Thank you very much. I think you're on mute. Ganesh.
That's an awesome explanation. Thank you so much, Abel. Appreciate that. Let's move on to the next speaker. Let me introduce Professor Dr. 𝗬𝗪 Komaras from Athens, Greece, to present on field trials of 5G-enabled UAVs on private infrastructure.
Thank you. Thank you very much for the opportunity to present our work. Let me share my screen. Okay. Switch to presentation mode. Okay, I think that you can see my screen. And thank you very much for the opportunity. I will mainly present the activities related to two European research projects and initiatives that we are participating, and one of it we are coordinating. It is about 5Genesis and 5G drones projects. And we'll focus on the first field trials that we have performed for testing UAVs and drones with 5G capabilities. For this activity, we have used a private 5G infrastructure, which is called 5Genesis, the 5Genesis European research project from Horizon 2020 framework that has as a main goal to build and deliver a private experimentation 5G facility, which will be capable of performing different trials for the execution of vertical experimentation. The 5Genesis facility is based on an experimentation blueprint that is used in order to build the facilities across different cities in Europe. So 5Genesis has infrastructure in Athens, Greece, in Malaga, Spain, in Limassol, Cyprus, in Surrey, in UK, and in Berlin, in Germany. Each facility in one of these cities has a special focus in vertical industry and facilitates the experimentation to that specific industry. In Athens, for example, among the other specializations, we have also a focus in UAVs and drones trials. Just a few words about the this experimentation facility that is available across Europe, it is not only an infrastructure, it's not only a 5G infrastructure, but it includes a whole experimentation tools and framework together with orchestration and management capabilities, which is called Open 5G Suite. This is an open source project, which is available for everyone to contribute and also to use in order to transform a typical 5G infrastructure to an experimentation facility. We are very proud because also 5Genesis uses the Katana Slice Manager, which is also another open source project, which has been initiated by Demokritos and the MNL Media Networks Lab, the lab that I belong to. And Katana is one of the first initiatives for slicing in 5G networks. So an external experimenter using 5Genesis has in his hands all the tools and the facilities needed in order to perform experiments and to receive useful results for the performance of a specific vertical service on top of a 5G infrastructure. But 5Genesis is not only the infrastructure, it's not only the tools that are offered to the experimenter. We have also defined a very detailed experimentation methodology, which defines all the steps of the 5G experiments and the different descriptions that the tests should include. For example, we define what is a scenario, what is a test case, what is a target metric, and all this is really useful in order the experimenter to break down its trial to different levels and to define the KPIs and the metrics to be assessed by the platform. All this experiment formalization is available at the 5Genesis website, and also we have respective research publications that further analyze and explain all this formalization, which we are proposed for different vertical industries to use and to adapt for their initial 5G transition and experimentation. Just a few words about the infrastructure that this experimentation facility in Europe offers. As you can see, we are using 5G infrastructure and technologies for different vendors, from Nokia, from Microsoft, from Huawei, and each site of the 5Genesis experimentation facility has also a different setup, ranging from standalone to non-standalone solutions, and also integrating 5G with 4G are other different options of integration according to the 3GPP. Also, we include also millimeter wave wireless link and facilities for testing respective services and applications. Okay, some of the results that we have received from the 5Genesis platform in terms of throughput, in terms of latency. As you can see, we have achieved the expectations, let's say, of the 5G, at least at the initial deployment, with a throughput reaching up to 500 megabps and latencies as low as 10 milliseconds. Also, we have the KPIs related to the time needed for the slice creation. As you can see, there are different times ranging from 45 seconds or 100 seconds, depending on the capabilities of the central data center or the edge computing node. And of course, we have also millimeter related delays which are extremely low, as low as 1 millisecond. And of course, we have experimentation with phones, mobile phones, commercially available phones. And as you can see, again, in this private infrastructure, we have reached KPIs, very good KPIs, very close to the ones expected for the 5G deployments. So, initial trials from vertical industries have started utilizing these 5G KPIs that Genesis platform offers. So we have, for example, trials related to police in Spain and to PPDR services. In Athens, we have initial trials with drones, where we have the communication channel and control channel shifted over 5G. I will present more details about this trial, but we have also included trials about satellite integration with 5G, as well as massive events like the Festival of Lights in Berlin, where the millimeter wave technology was tested. Let's shift to Athens 5G trials. We had recently some extended trials with 𝗬𝗵𝚻 drones, where as a first step, we considered to use 5G connectivity for controlling the drones. As you know, 3GPP considers very tight integration of the UAV industry with 5G as a first step to moderate, let's say, this industry, which currently is not standardized, and it will be very useful also for safety reasons to have a common access network and a common authentication, let's say, technology for the pilots to control and pilot the drones. So we have different drones that we have modified together with our partners, 𝗘𝘃𝗽𝗽, Kafatech, Robots Experts, and 𝗀𝘂𝗺𝗃, the mobile operator in Athens, in Greece, that provide us also the 5G connectivity. All these drones have been modified in order to have a 5G module on them and to allow appropriate control of them. So we used a stadium in Athens in order to perform the trials, and also 𝗀𝘂𝗽𝗽 facilities in Athens, where these drones were flight. Here is the stadium that we used. Just to mention that we used also edge technologies in order to deploy the flight controller of the drone. And also we had UTMs. The UTMs are traffic managers that show a drone flight. It's like a radar. And we tested also this very important to be integrated with the 5G system in order to have a real-time information about the drone flight. Here is the testing 5G deployment at the stadium. And here you can see the whole team that supported all these trials in October, took place. Okay, just to say that we performed two different test flights. One was semi-autonomous flight, which means that we use normal remote control to perform the takeoff, the liftoff of the drone, and then automated flight was performed with 5G. So the flight controller used the 5G connectivity in order to inject flight commands to the drone. And then again, the pilot used typical remote control to land the drone with safety. But we also performed fully automated tests where the drone lifted, performed the flight, had all the mission steps, and then landed with safety, fully automated with 5G remote connectivity without any human intervention. Of course, we had, for safety reasons, a pilot, just in case that something went wrong, to intervene. And just a few results, as you can see here are the flights that we performed with different position of the 5G antenna. In the one case, we had the position in that area of the stadium. We performed with different setups, with different pitch of the antenna, and we performed also assessments of the throughput in the different, let's say, position of the drone. And at the same time, in Poland and Austria, we had two UTMs, UAV traffic managers, that could provide in real time all the details of the flight, monitoring the position of the drone. The lessons learned, and I am concluding, were very interesting. First of all, we proved that 5G integration with UAV industry, including different components like UTMs, but also controlling the drone over 5G and utilizing edge technologies is feasible. The latencies that were very low due to the edge technologies allowed to have a safe flight, even if it was fully autonomous. And this creates a first step towards more complicated scenario with fully automated flights with a swarm of drones, and also supporting more advanced also scenario for vertical industries with drones that perform missions fully autonomous, and also with AI for a more sophisticated scenario. Also, another interesting finding is about the utilization of edge computing in the UAV industry, and I think that this is a must. And gradually, as the previous speaker mentioned, new applications that will use information from the OpenRAN or the Open Core should emerge in order to utilize the full capabilities of the 5G and also to unleash the full power of the UAV industry. Just I would like to thank you for this opportunity, just to mention that this is a teamwork, and I'm present here the 5Genesis partner as well as the 5G drones partner from the two projects. You can follow us on the social media and on our websites for more information and details on our work. Thank you very much, Kanis, for this kind invitation.
Brilliant explanation. Thank you, Professor Dr. Harilaos. I appreciate that. Let's move on to the next speaker. Let me introduce Aamer Hashmi from London, UK, to present on the 5G private network use cases.
Hello, everyone. Thank you very much, Ganesh. Can everyone see my screen here?
Yes.
Yeah, great. Thank you. Thank you again for the opportunity, and it's been fantastic listening to everyone's talks. What I'm going to be doing is talking about the 5G use cases. So I'm talking quite high level, so use cases and kind of application business benefits. But just before I start, just a quick introduction to me. My name's Aamer Hashmi, and I'm the CEO of 𝗀𝗃𝗃. We're a managed technology company, and we operate in a lot of the areas that some of the speakers have spoken about so far. So we have our own globally operating cloud. So we operate various applications kind of across the globe. We've fairly recently got more involved with 5G, mainly in partnership with Verizon. So Verizon are a good partner of ours. So we've been doing a lot of 5G work with them, and particularly talking about private 5G. So let me just move straight in, and what I'll do is I'll quickly just talk about 5G versus 4G. And I think the reason why I want to just talk about this briefly is just to, I mean, the speaker panel here will obviously know all of this already, but just for the benefits of the audience as well, you know, what are the kind of key differences between 4G and 5G? Abel had a really good slide earlier on which described the kind of differences or benefits of 5G, and hopefully they will come out of this kind of what we're looking at here. And essentially, you know, some of the key areas, and there are many more, that 5G gives us low latency, right? 5G gives us low latency, something that we didn't have before, because 4G doesn't allow us to have such low latency as 5G. 5G also gives us more of a download speed, yeah. Again, much more than 4G, and I think they're the key items to kind of recognize between 4G and 5G. There are lots of others. I know there are more advanced features like network slicing that we talked about earlier as well, and they give us tangible benefits on the business side of things. But one of the key enablers that I find, and we're finding that most customers really excited about, is around the kind of lower latency, increased throughput. Also the kind of geospatial benefits that 5G can give them, and I'll cover a couple of them now. So if I move on, so at airports, airport infrastructure, would typically combine Wi-Fi and public cellular network, so 4G network into kind of various environments. And customers use these networks as well as the operational parts of the airports. So as we know with Wi-Fi, depending on obviously the implementation of Wi-Fi, you have poor areas of reception, and you also have a mesh network that can sometimes be broken. So airports can really benefit from 5G because the kind of dependency on any kind of third-party wireless providers goes down. We talked earlier, the security aspects of private 5G, and you can design, airports can design their own 5G implementation, implement their own kind of custom security, different security layers. And the other area is that we mentioned earlier in one of the presentations about campuses, and private 5G is ideal for campuses because campuses typically are harder to cover using a blanket Wi-Fi network. You can do it; it's not that you can't do it, but again, for a campus and an airport, it typically is a campus. Private 5G is really good. So we can give all of the devices that are on the outskirts of the grounds, for example, much quicker network access, but we can also put more items around the perimeters, for example. So whereas the limitations currently and before were wiring, hard wiring devices and sensors, we can now ingesting that data and being able to sense many more items. So if I go on, so we've got healthcare. So in a recent studies, one of the largest addressable kind of markets for 5G, certainly in terms of top 10 kind of sectors, was healthcare. And again, we're talking about campuses, we're talking about hospitals. So we're talking about being able to audit and track equipment. One big problem that nearly all hospitals have, especially the larger hospital, the bigger the problem is the loss of equipment, because much equipment in hospitals is mobile. So there are various ways to audit and track equipment at the moment, but most of them are manual now. Using 5G enables us to real-time track that equipment. So even if it's going, and even if it's leaving the building, so we can really use the geospatial kind of benefits that 5G brings us, and track equipment, and that results in tangible savings, tangible monetary savings, and ultimately better service to patients. And then we've got various other solutions further down. So we've got intra-hospital monitoring, so we can do much more advanced monitoring within the hospital, remote consultations, specialist diagnosis, remote surgery, and teaching. Again, we can scale this up using a private 5G network, and through emergency response, we've got reliability, and through network slicing, we can prioritize the networks So we can have you know an emergency network that's totally kind of disturbance free, which is excellent for hospitals. So in terms of carbon emissions, so this is a great example that we thought we'd put here, because in the mining industry, this is 4G and 5G, but ultimately 5G did deliver some of these benefits. So Ericsson provided a 4G and 5G network to automate the great thing is that the end result, they were able to prove a 10% saving in fuel consumption, and that's simply because of the enablement that the private 5G network gave them. Sorry, in this case, this wasn't private 5G; it was general 5G. But the point is that it gave and delivered a tangible fuel consumption saving. So in especially for organizations like this, it was great for them to show that through a reduction of 9,400 metric tons of CO2, you know, they were able to actually make their operation and their business much more slick and versatile. So so that I thought that was a really good case study. I'm zooming through these, but we can always provide some more detail if need be on these. And then manufacturing. So again, some of my colleagues here in the panel have talked about manufacturing, and we were talking about 4.0 as well. One of the things in manufacturing that we find is that we have many sensors, many robots, for example. We have so many moving parts in manufacturing, and you know, private 5G, what it brings us the ability to connect and efficiently read and control all of these devices in pretty much real time through the low latency. Primarily, we can do it securely, and we can then take in that data as well, sensor data. We're moving, and we have been moving for some time to a much more real-time compute model for many industries, and especially in manufacturing, we can make real-time decisions. We were talking about AI earlier. We can also talk about machine learning. So we're, you know, machine learning models. If we're getting data real time, we can put them into machine learning models that can then give us better insight. We can use AI to make decisions in pretty much real time. And the other key thing is we can also take in all the data, much more data than we would before, again, through the general throughput that private 5G allows us to, and then once we've taken that data in, we can do whatever we want on that data. We can use edge computing to process that data very quickly locally. Yeah. Oh, I'm really sorry. Did I pop off there?
Yeah, there was couldn't able to hear for the last.
Sorry, apologies for that. I've had a few internet issues this morning. Can you hear me now?
Yes.
Yeah. Sorry. So I was just saying that in summary, you know, we've been really excited talking to various organizations, airports, some hospitals about how private 5G really enables them and gives them benefits, gives the doctors benefits, gives the actual business benefits as well, and the patients, for example, in terms of healthcare. So it's yeah, really exciting times. And you know, again, through the key values and the key kind of technical innovations and technical kind of forward not forward thinking, but the kind of technical cutting edge technical features, 5G really does give us some really big benefits on the application and business side of things. So it's really exciting. And I'd just like to say, yeah, just that's it. I was watching the time, and apologies for cutting off, but yeah, feel free to get in touch with me, get in touch with us. As I said before, we're doing a lot of work with Verizon around the private 5G area, particularly. And yeah, happy to speak to everyone. And I'd like to thank you again, Kezh, for allowing me to speak. And apologies for the slight cut off there.
That was a brilliant explanation. Thank you, Amir. Thank you so much. So let's have a 10 minutes Q&A session. If anyone on board have any questions on the topics discussed earlier. Maybe I could start first. You know, I have just one question here regarding on the 5G private network on the 28 gigahertz spectrum. Are there any commercially available on a 28 gigahertz in any part of the world, you know, when it comes to the mobile operators? Because as far as I know, the UEs or devices are still not available. Anyone who want to take this?
I can take this one. This is Abel from Airspan. So, Kezh, you're right. I mean, millimeter wave ecosystem is not mature enough. When we look at what is called a standalone, right? There are two types of architectures in 5G. When you see MNOs, well, I will say all the networks that we see in the world being launched in 5G, they are non-standalone, meaning that they use the existing 4G network as an anchor. Right, so all the signaling goes through 4G, and then you connect to 5G. So if we look at millimeter wave, you have devices in non-standalone. That means that our devices, they connect to 4G, and then they add the better of millimeter wave, and this is existing now. Of course, when we move to private networks and you look at the millimeter wave is very attractive for private networks because of these high bandwidth and high speeds, right? But the concern we have now is that there is a big interest in this millimeter wave spectrum for private networks, but the devices are not ready yet. Meaning that if you have only one frequency, a millimeter wave frequency, and you want to, and together with a 5G core, so that means a standalone. A standalone means that everything is 5G, 5G core, 5G radios. You don't have a device can set up a call just directly to millimeter wave. There is a workaround that you can do using this standalone architecture that is using the sub-6 as an anchor, meaning that you have a 5G sub-6 and you connect there your first better, and then when you see the millimeter wave, you have two options, either do a carrier aggregation or dual connectivity. But you are correct. Devices are not ready yet, at least in 2020. We are hopefully expecting that second half next year, we will have some millimeter wave standalone devices. So that's a good question.
Thank you.
So just to follow up on that, so in Latin America, I think David, you spoke a bit about spectrum. I just you didn't really talk about you know, the high frequencies. Is that the governments are currently not focused on that? Or
currently are not focused, but there are some plans following certain guidelines from other parts of the world. But at the current stage that we have in Latin America, the most hot topics, the hottest topics are 3.5 gigahertz in order to define which will be the final allocation and auctions, and the 6 gigahertz, I think is the hottest topic currently to be defined in Latin America, specifically for Brazil and also for Mexico.
Right. And just one last one for you, David. You did mention that for now, if the operators want to move into TV band, they need to pay. Is that already being implemented, or is that what people are saying would happen if they were to do it?
Yeah, it's a current discussions, specifically for Brazil is the case. We have a current discussion that I believe that in this week should be a definition probably after that will be certain consultations just to wrap up the topic. But it is in Brazil specifically because of the density that we have for the population. There are places where we don't have coverage of wireless technologies at all. And the only technology that arrives is a free TV satellite technology. So in that case, you can manage having some specific areas to be covered and another no because of the satellite nature of the coverage. So for this reason is that you need to make an arrangement of the spectrum or move the bands for the TVRO technologies. The most probable and suitable because of the trade-off of the cost will be to remain at 3.5 gigahertz, but with certain application of low noise filters. That is the point.
Okay, thank you.
I may have
okay.
In order to provide a full range to the mobile operators, about 100 megahertz, I think, or 80 megahertz. My question is the allocation of frequencies in Brazil or Latin America in general is up to mobile network operators only, or there is a plan also to provide frequencies directly to vertical industries like hospitals or manufacturers, airports, and etc. What is the intention?
Yeah, the intention, at least for the discussion that I have seen with the expert in the industries and also for Anatel, that is the telecom regulator, is that there are several industries in Brazil very well developed in order to take advantage of this allocation. The thing is that currently is being defined at suitable level. The upper band of the band C, 3.7 to 3.8 gigahertz as suitable. Then it comes potentially also the 6 gigahertz, that is the current discussion that we have, is also a possible band for that. And with lower attention, I will say that the highest frequency, like 24, 26, 28 gigahertz, are those ones that are exploring for private networks, but still there are no specific discussion for that. For example, in Peru, it's not 5G, but the first private network that we have in Peru has been for mining. And what happens, the mining in Peru normally are located in very isolated spaces, very isolated areas. And then Telefónica, jointly with Nokia, have deployed this LTE private network, reutilizing the frequencies that you have already using for commercial purposes. But yeah, in Latin America and also specifically in Brazil, I think this is the most probable country that will utilize will benefit with that. There are plans for that, and those are the frequencies that currently are being evaluating.
Thank you very much.
I can ask perhaps one last one from me. I think Amir would perhaps be the right person to answer, but anybody else can answer. I'm wondering what would be the new role perhaps of mobile virtual network operators, because in my mind, they look like private networks in a sense. Would their role with the coming of 5G change? Would the dynamics of mobile virtual networks, would it change, you think? You're on mute.
Sorry. Yeah. So, well, I mean, we're finding the network operators, the mobile network operators, they're moving along, and I like talking about this quite often. They're moving along the value chain, right? So they're, if we're familiar with value chain, it's where we kind of operate within a business, within an industry. So the mobile operators are supplying the, they're supplying the equipment, but they're really selling the equipment based on business benefit, to commercial organizations. So what they're doing is that they're taking a much more consultative approach, and that's what we're seeing. I mean, we have a very limited view compared to obviously such distinguished panelists, but certainly what we're seeing is that they're much more consultative. So I was talking about the insights that we generate through, or the insights that we can generate through the enablement of a campus or an organization with 5G. That's what they're using to be able to sell 5G, sell 5G effectively. To say, well, to an airport, well, look, you can actually geolocate people within the airport much easier. So, for example, you have people traveling through, duty free to the shops. We can actually locate them better than with Wi-Fi, as we all know. We can actually locate people with Wi-Fi depending on various conditions that need to be met. But through 5G, we can do that much more reliably, much more accurately, potentially, because we're not locked down to APs. And therefore, we can give you a benefit. We can give your retailers benefits because we can track people. We can remind them that someone, John Doe is coming along, who bought, last year he bought X amount of goods from you and spent so much money. You can, he could spend so much with you now. So they're really they're changing in the sense that they're selling more business benefit on top of the kind of technical solution. That's what we're finding.
Well, thank you. And I just wanted to clarify, is mobile virtual network operators, though, do you think that they might have a new role? I suppose mobile virtual networks, the ones that sort of run on other people's, equipment.
If I may add from Amir's
Thank you, Amir,
answer.
Yes,
what we see mobile virtual networks operators is that they are presenting them as a new role, still as a mobile network operator. Like, for example, Vodafone was quite clear saying that they see themselves as system integrators as well, right, of these new software vendors. And also we can see Rakuten, right? Rakuten Japan, the first virtualized OpenRAN 4G 5G network. They created like a company called RCP, Rakuten Communication Platform, that actually what they do is like they look like a 5G network as a service. So they install for you this virtual platform, right? And they can have some of the management in the center. So this is for mobile networks. When we look at the private networks, if the countries that they don't have frequencies dedicated to private networks, what is going to happen is that the MNOs, the operators, are going to have a key role here, right? And they're going to be the ones who offer these private networks to their customers, meaning that thanks to 5G and virtualization, they can create these, for example, these network slicing, so they can still, the customer can have the private network on their own, so meaning that their data is privately in their premises, but the management of the network is going to be by the MNO, thanks to these new 5G applications and the virtualization, that you can move parts of the data plane into the premises of the customer. That this didn't exist, for example, in 4G, right? We didn't have network slicing and we didn't have this type of virtualization. So I think that MNOs are going to have a bigger role in countries when you don't have dedicated frequencies. Maybe also they will become competitors in countries when you have dedicated frequencies, like CBRS, for example, European countries like Germany, the UK, France, right? But I think that they are evolving to these markets. As Amir was saying, there is a big opportunity here, and they're moving along this opportunity chain.
If I may add here, like for MVNO specifically, they need to differentiate themselves, because most probably they don't own the assets, so the competition will be difficult for them. So here, maybe in Australia and Asia Pac, some of them need to start working on over the top. So instead of only providing mobile, they need to start combining value-added services, gaming, mobile, be the provider of the edge computing services to the end user. So this will be the differentiated point. Another trend which which also start seeing here in Australia, that if I'm an MNO and I have multiple virtual operator using my services, the big MNO start acquiring this virtual operator, trying to, as example, to increase their footprint, increase their customers, because I'm thinking they are planning to do this instead of MVNO become like a competitor for them. So this is what I'm seeing here in my region.
Yes, I'd like to add that, well, countries like Germany that have actually devoted specific frequencies for 5G or local 5G private networks are the ones that are driving most innovation, because in the countries where MNOs have all the spectrum, at the end they are controlling the market, and it's also true that there is a business model for the combination of a private network and the public one, because it will be impossible to guarantee coverage with a private local network outside the building, or whenever you have like even a campus, sometimes the local network will not have enough coverage. So in Germany, those are referred to as campus networks. Like there is a combination of both. So I think that at the end is like in the US, thanks to this CBRS spectrum. This is an area with a lot of innovation right now, and I'm sure there will be plenty of new business models in the future, but each country will have like the constraints given by the spectrum, and it could happen that some countries they are slower because of the spectrum regulation.
Just to add also on this discussion, that for sure the expectations for leading the innovation is in the private networks. I don't believe that a mobile network operator will open its RAN or its core to expose native APIs to third parties in order to build applications or services. So it's the private networks that will initiate this 5G, let's say, native applications development, 5G native services to start with, and the market gradually to proceed with the 5G. So I strongly believe that the OpenRAN solution, like 𝗬𝗪 discusses and etc., is I think the initiative is for the private networks first, and then for the mobile operators.
But see, that's quite an interesting part when it comes to the spectrum regulation issues, right? Because it's quite not all the countries are willing to actually open up to the vertical industries. You know, when it comes to maybe 28 gigahertz, yes, but when it comes to the 3.5, it's going to be tough. Many countries are not willing to open up that to the vertical markets. So, yeah, I'm not sure how this is going to be in the next 5 years. Yeah, like in Malaysia, yes, 28 gigahertz was given just purely for vertical, but 3.5 is just close to the mobile network operators.
May I ask something, 𝗪𝗺𝗻𝗁, if possible, about the use case that presented for Industry 4 that you mentioned that has been delayed a lot, etc. Just if you can provide some further details, if there is any progress with TSN integration with 5G and all this time-sensitive and deterministic networking with 5G. Do you have any more details on that?
Yes, so we are actually planning to demonstrate 5G TSN, and well, implementing even release 16 features, and well, following release 17. So it might even possible that during the project lifetime we demonstrate some 5G TSN release 17 features as prototypes. But well, this use case is the slowest in our project, and well, I hope I will be able to report more information soon. But the other use cases are progressing very well. We are planning some first integrations in spring next year, demonstrations in summer. For the Industry 4.0 use case, we don't have exact timing yet because of this delay, but well, we will definitely push for the timing aspects in this use case.
Okay, thank you. Thank you.
Yeah, no problem.
All right. So this session has come to an end, and I would like to express my sincere appreciation. I'm so grateful to all of the speakers. I really appreciate for your time and effort to make this event happen. Thank you, David Gallegos. Thank you, Professor David Gomez-Baquero. Thank you, Professor Dr. 𝗬𝗪𝗂𝗪𝗃𝗍. Thank you, 𝗚𝗵𝐻𝗎𝗍. Thank you, Mohammad Radwan. Thank you, 𝗵𝗪𝗪𝗪. And thank you to Christopher Luanga, who on behalf of NTU Singapore, to host us this platform. I really appreciate for your time. Thank you, guys.
Thank you, Ganesh. Thank you,
Thank you
everyone.
very much.
Take care.
Thank you.
Thank you. See you.
Thank you very much, everyone. Very nice to meet you.
Thank you, everyone.